Good morning. So we're going to go ahead and go over our retirement account. Okay. So this is for section 9.1. Today is the 7th. And our essential question for the section, everybody, is how can you save for retirement? So we've talked about Social Security before. So Social Security is only supposed to be for about 40% of what you're going to pay. Okay. So what we have is so when you do a retirement account, so it's called an IRA. So you pay taxes when you take that money out. So when you retire, you pay the taxes later. So individual retirement account. So IRA stands for an individual retirement account. So IRA. And if it's tax exempt, that means that you never pay taxes on it. So often people will do is they get close to retirement, they'll change their IRA to what's called a Roth IRA so that they don't have to pay taxes on it when they retire and start taking that money out of the retirement account. Okay, so let's do an example. So let's say everybody that Maria is 25 years old and she wants to retire. When she is 60. Okay, if she deposits $500, so she's going to deposit $500 every month. At 3.8% compounded monthly. Okay, so this is what we call a periodic investment. So remember we talked about this before, like you think about the tide, so they go in and out every day, periodic cycle. So this is, so how much? So she's going to deposit $500 every month, and we want to know how much will she have. So how much money will she have? Okay. So we're going to use our balance formula, everybody. So we used this last semester in chapter 3. So it's another one of our lovely formulas. So the balance formula is going to be principal times 1, so double parentheses, 1 plus the rate divided by number of times compounded, raised to the number of times compounded times the time, minus 1, all over the rate divided by n. Okay, so just to remind everybody what everything stands for. So B is for the balance. So what she wants to, how much she'll have in the account. P is for periodic deposit, and everybody, that's the most common. So most people will deposit it like so bi-weekly when they get paid, or every monthly. R is the rate as a decimal. N is the number of times compounded per year. And T is the time in years. Okay, so we're going to go ahead and identify all the variables for this, everybody. So, so just like we did before, so she's going to deposit $500 as the principal. Our rate is going to be 0.038. Okay, so remember, drop the percent sign, go to left, add the decimal and 0. And then it's compounded monthly. Okay, so it's going to be 12 months in a year. Time is going to be 60 minus 25. So 35 years. So she wants to retire in 35 years. So we're going to go ahead and use the balance formula in this one. So it's going to be 500 times 1 plus the rate, so 0.038 divided by 12, raised to the 12 times 35. Remember to scroll left and do minus 1, double parentheses, so 2 parentheses here, everybody, all over the rate, so 0.038 divided by 12. Okay, and you're going to go to decimals.com for this one. The good part about this, everybody, I know you're like, oh my gosh, this is so much to put in, but again, just make sure you're getting all those parentheses in, and up here I did not put the double parentheses, so that you put the pairs in, okay, because otherwise we won't have our pairs of parentheses here, and that won't be good. So we need pairs, otherwise it'll give you an error message. Okay, let's go to decimals. So decimals. So she wants to deposit $500, and the rate is, so you go in and change the rate. Create. It's going to be for 35 years. Okay, and so that's how much money she is going to have. So for her balance, so she's going to have $437,858.88. Okay, so the next part we're going to talk about, everybody, is when we have our tax table. Okay, so we have our tax table here. Okay, so the reason people contribute to retirement accounts is to help them save money. Okay, so let's suppose that Logan, okay, so he made $78,500 last year, and he invested $500 a month into his individual retirement account. And what we want to know is how much does he save on taxes? Okay. Okay, so how we figure this out, everybody, it's the current tax. Okay, so current tax minus the new tax is going to give you the savings, which is the difference. Okay, so again, so it's the current tax. So this is the current tax minus the new tax. Okay, so let's show you how to figure it out. So using our table, so if he made, so we're going to kind of do this in steps. So every month he deposited $500, so 12 times 500 is 6,000. Okay. So his current tax would be 15,975. minus his new tax. Okay, so we're going to take that 78,500 minus what he contributed into his IRA, and we get 72,500. So now his new tax is 14,475. So the difference or savings is $1,500. Okay, next part. So we're still talking about individual retirement accounts. Today is still the 7th. Okay, so Jose has a taxable income of $45,000, and he pays about 22% in taxes. He contributed $4,000 to his individual retirement account. Okay, so we're going to do 45,000 times 22%. That's his current tax minus 45,000 minus 4,000 times 22%. So this is how to do it if you don't have the table, everybody, because what we're looking at here, everybody, is that we don't have the table. So we're having to use the percent that we have. Okay, so we're going to get, so 9,900, and then it's going to be reduced to $9,020. Okay. And so that means that Jose would save $880 by doing an individual retirement account. Okay. So that would be, so how much would Jose reduce his tax liability? Everybody remember, tax liability is how much you're responsible for paying. Okay, so that's how much he reduced his tax liability. Okay, let's do another example, everybody. So let's say, so we have Destiny. Just find like a darker color here. Okay, so Destiny has deposits $3,000 at 3 1/10% compounded continuously when she's 25 years old. Okay, so, and we want to know how much will be in the account, will be in the account when she is 60. Okay, so when Destiny is 60 years old, how much money would she have? So remember, everybody, this formula is going to be, it's our balance formula. So it's going to be balance is equal to principal ERT. Okay, so we're going to do 3,000 is our principal. times E, and then our rate. So our rate is going to be 0.031 times, and then for our time, everybody, it's going to be 60 minus 25, so 35 years. Okay. And what you want to use for this one, everybody, is Decimal Scientific. So decimals.com /scientific. Okay, so make sure everybody, when you're into this end, you go to function to get E. Okay, so that's where they have E. E is over here. So I did 3,000 times E, and then it automatically raises it 0.031 times 35. Notice you do have to do parentheses around it. So we get the balance is equal to $8,878.32. Everybody remember, we always round to the tenth place. Okay, so let's look at taxes. So the reason, everybody, you're like, oh, why would people, so you've seen that they save money. Well, let's say somebody goes, oh, I'm not 59 and a half yet. I want to make a withdrawal from my savings account. Well, we're going to show you why that's not a good idea. People will even do it, they take out a second mortgage before they do that. Okay, so let's say that you're married, filing separately, and you wanted to withdraw $50,000 from your individual retirement account. You earned $97,000. Okay. So 97,000, because they are going to include that in your income, times the 50,000 is 147,000. Okay. So just so you know, before, with just the 97,000, your taxes was 21,539,000. Okay. So now we're going to go ahead and use our table. So it's going to be here, not over 100,000, but not over 178,850. So I'm going to put the 147,000 into here. Okay. And then we multiply it by 0.33. 33% is the decimal. And I got 48,510. And then remember subtraction amount, so we're going to subtract that 10,635 and 50 cents. So we get $37,874.50. What is it, 50? Okay, so penalties. So everybody, so penalties. So again, like I said, this is why people will even take out a second mortgage. If you withdraw, okay, so if you withdrew from your individual retirement account, before you're 59 and a half, so this is for any of your retirement accounts, there's a 10% penalty. And you have to pay taxes on it. Okay. So let's say, so we have the 50,000 times 10% as a decimal. So that penalty is going to be $5,000. Okay. So we're going to have to add that on to what we're already having to pay. Okay. So total taxes and penalties. So let's look, everybody. So this is to figure out the total. Okay, so we had $37,874.50 plus that 5,000. We add those together. Add them together. What do we got? $42,874.50. Okay. Minus. So everybody, this is what we're figuring out, how much extra you paid. Minus what you paid your original tax liability was, so that 21,539. So we subtract those two, and we get $21,335.50. Okay, so that's how much you paid extra by taking out that $50,000 early. It's a lot of money. Okay, so now you see why people don't do that usually. Try not to. Okay, so let's go ahead and go over a couple examples. So I just want you to look at what we're doing. Okay. Okay, so I just want you to notice on the worksheet, so make sure everybody you are identifying the variables. So Francine opened a retirement account, the annual percentage rate of 2 2/10 compounded monthly. She plans to retire in 24 years. How much will I have in the account if she deposits $3,350? How much will she have? Remember, that means that we're doing balance. Okay, so we're solving for the balance. So I'm going to put 350.022. I'm going to drop the percent sign, go to the left, add the decimal and the 0, or you can divide by 100. So everybody, whichever one works. Okay, I definitely want to use decimals.com, so everybody use decimals.com. Okay, and compounded monthly. Okay, so it says up here compounded monthly, so that means that N is 12, time is 24 years. Okay, then we're going to go ahead and put it all in. Make sure, everybody, that you have your pairs of parentheses there. Gotta have this, everybody. Can't emphasize that enough. Gotta have the pairs. Just won't work without it. They'll tell you, nope. Okay. So pairs of parentheses, make sure that you scroll left and do the -1. And then, yep, you got all this. Okay, so she would get $132,628.06. So that would be our balance. Okay, if we had an example where we had to figure out the time, so this one, Dwayne is 24 years old. He wants to retire when he's 55. So 55 minus 24 is going to give us 31. Okay. So he's going to contribute $180 every month. The interest rate is going to be 0.0225 divided by 12. Remember, it's going to be raised to the 12 times 31, so N times T minus 1. Remember, everybody, pairs of parentheses, still got to have those pairs. Okay, and then it's the rate divided by 12 again. Okay, everybody, definitely use decimals.com for this. Let's double check because I thought we had continuous on here. Okay, so for this one, using tax, so use the tax table in your notes. It's actually on the worksheet for you. So it's going to be 79,000 times 26%, because he's paying 26% in taxes. If he contributes $50 a month for Harold, so 50 times 12 is 600. So 79,000 minus 600 times 26%. So it's going to be 17,680 in taxes. So his original tax liability is $20,280 minus $17,680. So the difference, or how much he saved, is $2,600. Okay, everybody, you got this. Okay, so on the next worksheet, everybody, we're doing periodic. It says how much should Freddie deposit? So we're solving for deposit. Okay, so you're going to go ahead and put in. So he wants to have $500,000. So $500,000. The rate is going to be 0.024, compounded monthly, and is 12. Time is 30 years. Okay, and so we're going to use our periodic deposit formula. So that's this one. Okay, you do need to put parentheses around this part using decimals. And then the bottom, make sure you just do your pairs or parentheses. Okay, so it's going to be $500,000 times the rate, so 0.024 divided by 12, divided by 1 plus the rate divided by 12, raised to the n times t minus 1. So we get $949.71. Okay, so these are where we're doing the continuous ones. So Sarah's going to deposit $9,000. So that's our balance. The rate is going to be 0.02429, sorry. And time, she's going to be 25 years old. She wants to retire. Know how much she'll have when she's 50. So 50 minus 25. So we get 25. I'm going to use decimals.com. If it's called today. /scientific for this one, so I can have the E. So our formula for this one is the balance E raised to the R times T. Okay. And we're looking for the balance. So 9,000 times E raised to the 0.029 times 25. Okay, so when you do this, everybody, so do this on decimals. Okay, so 9,000 times, so I do times, go to function, E, I go back to the main, I do parentheses, 0.029 times 25 years, close the parentheses, and we get our answer. Okay. So Sarah, so the balance, she would have 18,582 and 58. Okay, everybody got this.